Hi, and here we are at section 5.1. This is going to be the first of a couple lessons that we're going to have in this chapter here. Big picture, what we're looking at, how can density curve represent a set of data? And we can recognize shapes of density curves. We can use standard deviations in the normal curve to determine information about a data set. So this all comes down to our normal density curves. So what is a density curve? You watched a little introductory video on those prior to this. It's a curve that shows the proportion of observations in a region under the curve. The total area of the curve is 1. So if I could draw your attention to this red line, we're going to smooth out that curve, that histogram underneath, and we're going to focus in on that. So the total area under that curve is going to be 1. It comes from 100% of the observations that we get. So we've got a bunch of data. The area under the curve is 1, and we're looking at percentages. We're looking at 100% and what percent of it falls within each segment here, or each category that we're looking at. So density curve, basically what we're doing is we're smoothing out the histogram, and we're making it look, we're making it take on the shape that we have, and we can make some inferences from there. So, you looked at a situation here where you're skewed left, your curve is going to look skewed left. You look at something that's maybe a little bit skewed right, your curve is going to look skewed right. So you can make the smooth curve based on the proportions, based on the information, the data that you have on there. So a couple examples of density curves that we're going to look at. We're going to skip over these. If you want to copy them down in your notes, you can pause the video and you can do that on your own. Same thing here. When we talk about mean, the only thing I will say is we've used X-bar before, mean. We're going to call it mu in this chapter. So mu, what it looks like, it's like a U with a tail. It's the Greek letter mu, and that stands for the mean. So it's called mu is the mean. Now, the normal curve, this is going to be the symmetric bell-shaped density curves. We can completely describe them with the mean and the standard deviation. Remember, the mean is going to be the center of the distribution. The mean is going to be that mu. The standard deviation determines the shape. That's going to be the little sigma. So we've got a baby sigma. It's like an O with a hat. So baby sigma. So with mu and sigma, we can completely describe what the normal curve looks like using that information, because the mean determines the location of where it is, and the standard deviation is going to determine how spread out that information is. So, if you've got a lower mean, your standard deviation is going to be more spread out, and you're going to have more spread out data, higher standard deviation. If your mean is taller, it's going to draw in that standard deviation, because remember, it's all 100%. The area under this curve is just 1. So if we go higher, we have to go in skinnier. If we go lower, we have to go out wider. So keep that in mind as you work your way through here. And we can normalize, we can normalize things that are approximately normal. I should say standardize things that are approximately normal as we talk about proportions of them. So once again, the normal curve can be described with the mean and standard deviation. Now, the normal curve, we are going to use the 68, 95, 99.7 rule. I know it just rolls right off the tongue. Now, what that means is we've got 3 standard deviations above and 3 standard deviations below. So if you look at this chart here that we have a normal curve. And I'm going to ask you to copy this down, because this is going to be very useful as we work our way through this chapter here. But if you look, we've got our mean. Now, within 1 standard deviation of the mean, so we're talking a standard deviation below to a standard deviation above. So we're saying 1 standard deviation about the mean, we're going to have 68% of our observations are going to fall within there. 68% of our observations are going to fall within that 1 standard deviation of the mean. Now, 2 standard deviations of the mean, so we're going 2 below to 2 above. That's going to fit about 95% of your data. So 95% of your observations are going to fall within 2 standard deviations of that mean. Now, over here, within 3 standard deviations, so 1, 2, 3 standard deviations, we're going to get 99.7% of our data. So just about everything is going to be within 3 standard deviations of the mean. Now, notice the further you go out, so we're going from 68 to 95, so this line is going down, so the area under the curve in this segment is not the area in the curve under this segment. So those two aren't the same. This is going to be smaller. So the further you go away from the mean, the more rare you become in the positive direction and this, because there's just simply less observations out here as you move out 1, 2 standard deviations above or below the mean. Almost 2/3 or over 2/3 of your data points are going to be within 1 standard deviation of the mean. So the bulk of them are right close to the mean. The further you go away, the more rare you become. So let's break it down right here. We've got 68% of our observations are within 1 standard deviation of the mean. That means that 34% is going to go in this chunk and 34% is going to go in this chunk. So this portion right here, from here to here, there's 34% of your observations. Likewise, from here to here. Okay, let's move out 1. So we go from 68 to 95. So notice there's 27% difference when I subtract those two. That 27% difference gets split between these two spaces right there. So what I have is 13.5% and a 13.5%. Okay, now going out, I'm going from 95 to 99.7. So if you notice that is 4.7% needs to get split up amongst those two spaces. So what we have is in here, we have a 2.35%. And over here, we have a 2.35%. So that's what we have there. Now, what I want you to do is I want you to think 99.7. That means that we have 0.3% of our observations are going to fall outside. So 0.3% split amongst those other two spaces. Outside, we have 0.15%. And you can imagine how rare it would be to be 0.15%. So it's not a very, very big company out there that you're going to have when you're that far outside of the mean. So the further away from the mean you become, the more rare you become, and you can see as evidenced by these percentages that we're working with there. So this information right here: 68% of all observations fall within 1 standard deviation of the mean. 95% of observations fall within 2 standard deviations of the mean, and 99.7% of all observations fall within 3 standard deviations of the mean. So if you look, how do you denote that? Mean is the mu, and 1 standard deviation, so we're at mean mu. We're going 1 standard deviation above, so we're going to add 1 standard deviation. Here we're at the mean, we're going 2 standard deviations above. Here we're at the mean, we're going 3 standard deviations above. So keep these things in mind as we go through. We'll do a practice problem here that kind of shows you how things work out here when we do that. So a test given in a statistics class has a mean score of 20 and a standard deviation of 1.5. Let me just get my colors ready here. And a standard deviation of 1.5. About what percentage of students earned lower than a 20, higher than an 18.5, between an 18.5 and a 23? So to draw your normal curve, I always like putting a line down, and this may take a couple tries, so we'll see if I can get it. So what you're going to do is you're going to start on one side, you're going to go up, you're going to reach a peak, and you're going to come back down. And it's okay if you don't get it right the first time. It might take a couple tries to do it. So just practice drawing it a few times. It's easiest if you just go in one smooth pattern. As you can see, it's not perfect even when I do it. But what you're looking at here is a normal curve. So this is our approximation. So now our mean in this situation is going to be, what does it say? It says our mean is 20. So we know that this is going to be 20, so go to the peak. That's a 20. Now, how do you find your standard deviations? If you go about, so if you follow this line, what you'll notice is that at some point you're going to curve down, curve down, curve down. It's going to flatten out, and then it's going to start curving up. So look for right the middle, right where it changes from curving down to curving up. So we can say somewhere right in here. So we'll say that this is my standard deviation. Now, my standard deviation for this graph is 1.5. So what I can do, instead of doing 20 minus 1.5, since it's one standard deviation, I can just say that this is going to be 18.5. Okay? And I'm going to take the same distance. So I have some tools here. You can use your hands, you can use your fingers, whatever you need to. I have some tools here that will allow me to do this. But what I'm going to do is I'm going to say, all right, this is my distance for my standard deviation. I can say that this right here is going to be my standard deviation, just to keep it consistent. So now this is going to be one standard deviation above. Instead of doing 20 plus 1 times 1.5, I can just say that that's, well, 21.5. Now you're going to want to go 3 standard deviations above and 3 standard deviations below. So my second standard deviation here below is going to be approximately right there. And if I go one more standard deviation below, instead of doing 20 minus 2 times 1.5, what I can do is I can just count down by 1.5, because that's basically all you're doing with this. So this is going to be 17. Let's take that and go one more down. And my third standard deviation is going to be about right here. And this is going to be, once again, instead of doing 3 times that, I can just count backwards, and I can say that this is going to be 15.5. Now, I'm going to go in, I'm going to try to grab that. Yep, come on with me. There we go. And we're going one above. We're going to go another one above. And we're going to go here. And I'm going to say that this is an additional 1.5. So 1.5 up here, 1.5 up here. This lands me at 23. And then let's do one more time. Let's do one more time right here. And let's call this one 24.5. So those are our standard deviations right there that we're working with. Typically, we want to go 3. You don't need to go any more than that. And you definitely don't want to go any less than that. So what we have here is our normal curve. And I'm going to bring you up to the top here, and we're going to look at this. Because what we're going to do is we're going to refer back to this. And what you can do as you draw them, if it helps you out, what you can do is you can go in and you can sketch, okay, I know that this is 34%, and it might not be a bad idea to do this. I know that that's 34%. I know that this is 13.5%. I know that this is also 13.5%. I know that this is 2.35%. I know that this is 2.35%, and this is 0.15%. This is 0.15%. Because now what you can do is you can utilize that property, and you can just add up the chunks that you have there. So what percentage scored less than a 20? Now, a couple different ways you can go about doing this. If you look at 20, you say, hey, that's my mean. Well, it's your mean. Yes, that means half of the people scored less than that. So that's one way of looking at it. So we know that 50% scored less than 20. What we can do is we can say, okay, I know that I'm looking less than 20, so I'm looking from this point over. So that's one of these, one of these, one of these, and one of these. So it's going to be 34 plus 13.5 plus 2.35 plus 0.15. And if you add these up, this is 2.5. 2.5 plus this is 16. 16 plus that is 50. So it turns out to be 50 either way. So you can add it up by chunk as well. So when you look at that, if you don't want to say, okay, the mean above, below, whatever it is, you can just add up the chunks that you have. So higher than an 18.5. So 18.5 is over here. So we're looking at anybody scored anything over here. So if I could shade this in, I would say, okay, it's going to be this one. It's going to be this one. It's going to be this one, it's going to be this one, and it's going to be this tiny little one down there. So what I can do is now I can add up those numbers. I know that, I can take some shortcuts as well. I could certainly go in and add them all up, or I could say, hey, I know that this is 50% right here, and I know that this is going to be 34%, so I can say that it's going to be 84%. That's going to be under that curve right there. So 84% of my observations are going to be above an 18.5. So what did I say, 84%? And once again, you can say, I'm going to add up 34 plus 34 plus, yada, 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 and you can go from there. So that's what we're looking at with that one. Now, we're looking between an 18.5 and a 23. So 18.5 and a 23. So this, we're going not just on oops, I missed the mark there. We're going beyond just one standard deviation on one side, and we're stopping at one standard deviation on the other side. So that's what we're looking at. So in a situation like this, you're just going to want to add up your chunks. So add up that plus that plus that. Or you could look at this and say, hey, I know that this is 68%. I'm going to add 13.5 to it as well. And what you'll find out when you add all those up is that you're going to land on 81.5% of your observations fall within there. So that's the 68, 95, 99.7 rule. So once again, it's going to be worth your time to either screenshot this and have it with you, or personally, I'd like you to sketch it out so you get a little bit of that pencil to brain action going on. But keep this handy because we're living on the standard deviations for now. Tomorrow we'll talk about what happens when you go in between the standard deviations, but that right there is your introduction to